we have seen the distortion of the shape. Now we will be looking into the one more aspect of the shape, or one more tool in measures of shape, that is kurtosis. So kurtosis is a measure of the peakedness or flatness. It's the measure of the peakedness or flatness of the distribution of data. It indicates whether the data is more peaked, that's a leptokurtic, or less peaked, which is platykurtic, than a normal distribution. Let's look into the following illustration. At the center, that's a normal distribution. We call it as a normal distribution. So in normal distribution, we also call it as a mesokurtic distribution. If kurtosis is close to the zero, if kurtosis is closer to the zero, the distribution is approximately normally distributed. Again, I'm repeating, if the kurtosis is close to the zero, the distribution is approximately normally distributed. Now, if kurtosis is less than zero, if kurtosis is less than zero, the distribution is platykurtic, or less peaked compared to a normal distribution that you can see on the screen. If this is called a low degree of peakedness, low degree of peakedness is platykurtic distribution. Then we have a leptokurtic. If kurtosis is greater than 0, the distribution is leptokurtic, or more peaked compared to a normal distribution if it has a high degree of peakedness. If kurtosis is greater than 0, that's called high degree of peakedness. That's called leptokurtic distribution. You see that again? Leptokurtic distribution which has a high degree of peakedness. Let's look into this with one example, then we will understand more about that kurtosis. Okay. Kurtosis. Kurto means, let me see, lepto means little, platy means flat, and kurto means bulging. Kurtos means bulging. So let me write down here. Kurtos is equal to bulging, and lepto means little, leptos means a little, platy means flat. Leptos, little, platy means flat. That's it. Let's take the similar example that DF. This is what the data frame for us we have used in earlier. For the same one, we are going to measure the kurtosis. So kurtosis is equal to DF of scores and then kurtosis. So the kurtosis has been calculated. Now let me check the degree of kurtosis using the print operation. Print, that's kurtosis, and it's a kurtosis. It's minus 0.9374. The degree of kurtosis is a negative. If it is a negative kurtosis, what do we call? The negative kurtosis is called a platy-kurtic. Platy-kurtic distribution. Platy-kurtic. Platy means flat. Let me get back to this. So platy means flat, kurtik means bulging. So platy kurtik is flat bulging. So let's see how does it look like. So obviously it's scores, it won't be narrow, that's for sure. That's what it's saying, data. Yes, obviously it's not narrow, it's a flat, it's a flat, it's a flat one, it's a platy kurtik, it's a flat one. Okay, next let's see more examples for this. But before we look into the more example, I just want to reiterate what is kurtosis. Kurtosis is a statistical measure that describes the shape of the probability distribution of a data set. It quantifies the degree to which the data distribution deviates from a normal distribution in terms of the peakedness and thickness of the tails. So, two things it considers: the degrees of peakedness and thickness of the tails. So, in simpler terms, kurtosis tells us whether the data has heavy tails, outliers, or light tails. That's a lack of outliers. Let me write it down. So, kurtosis tells us whether the data has heavy tails, outliers, or light tails, which is nothing but the lack of outliers. Lack of outliers compared to a normal distribution. Compared to the normal distribution. Okay, this is a kurtosis for us. As we have discussed earlier, there are three common types of kurtosis. That is mesokurtosis. The first one is mesokurtosis. A data set with kurtosis close to 0 is called mesokurtosis. And it has a similar tail behavior as a normal distribution. And then you have a leptokurtosis or leptokurtic. Lepto means narrow, kurtic means bulging. Narrow bulging is called a leptokurtic. A data set with positive kurtosis greater than 0 is called leptokurtic, which means it has heavy tails and is more peaked in the center compared to a normal distribution. Then we have platy kurtic. Platy is again flat. Kurtic bulging, flat bulging. A data set with a negative kurtosis is called a platy kurtic, which means it has a light tails. Light tails and is less peaked in the center compared to the normal distribution. Let's do more examples for this. Let me go up directly. Customers, work experience, skew, family size, a PD, players. Let me look into this first. Yep, B. So players, I'll say height. This time I'm gonna say kurtosis. Kurtosis. Kurtosis is the method I'm gonna use here. Kurtosis. Yes, you got it. But Yes, this is 0.06. Of course, it's a positive one, but it's very close to the this thing. So that's why the peakedness and then tail, the thickness of the tail, the peakedness of the curve and thickness of the tail is closer to the mesokurtic distribution. What do we call that? Mesokurtic distribution. And you can see that it's closer to the normal distribution, closer, very closer to the normal distribution. That's how the soccer players heights were distributed. It's mesokurtic, and then the kurtosis value is 0.065. Now let's look into the weight of the soccer players and see how it is how it will be distributed. Kurtosis, oh, it's too much. It's 5.884. It's greater than 1. It's greater than 0. So if it is greater than 0, it's a leptokurtic distribution. So high degree of peakness and high degree of peakness. Let's see that the peak is too much. You see that the peak is too high, too big peak. So 5.8 literally tells the peakness of the degree of peakness. Kurtosis is a degree of peakness, and here you can see the huge amount of peak. You have the lot of data at this level, very high peak with the low tails, very high peak. Okay, you just see this. You compare the both. This is mesokurtic. This is lepti. This is leptokurtic. Okay, so leptokurtic, a data set with a positive kurtosis is called leptokurtic, which means it has heavy tails. You see that the heavy tails and is more peaked. If it is greater than 0, the tails are also heavy, and then the peak is also heavy in the center compared to the normal distribution. You see that the heavy peaked as well as heavy on tails. That's what uh, is called leptokurtic. Let me put it here. This one is leptokurtic 5. The top one is mesokurtic. These are all real data. It's not cooked up data. Okay. So now let's look into the customers data. This time I'm going to go with the family size. So family size customers, kurtosis, kurtosis, and it's negative. That's minus 1.16. So this is supposed to be the platykurtic. Let's see. Of course, this is a flat. It's not, the peakedness is not that much. You see that the data is all around here, all around here. So platykurtic, a data set with a negative kurtosis is called a platykurtic, which means it has a light tails and is less peaked in the center compared to the normal distribution. So it's called platykurtic. Yep. So we have seen all three, mesokurtic, leptokurtic, and platykurtic from the data sets. And let's see, this should be, as per my understanding, it should be leptokurtic. Let me see the customer's work experience. Customers. Yep. Let me put it that. Work experience, and then it's kurtosis. Yep, it's minus 0.466. Of course, it's a negative one. So the negative is nothing but a negative. Kurtosis is a platykurtic. Platykurtic is a flat bulging. A platykurtic is a flat bulging. Okay, and okay, this one. Let's see the age. What's gonna happen? We can predict this customer's age and kurtosis. Okay, that's what. Okay, this is also negative. So negative is again a, a kurtosis which is lesser than 0 is a platykurtic, a flat one, and that you can see on screen. It's by and large, it's this is also flat one. So this is also platykurtic, and sorry. So this is a work experience anyway that we have seen. Work experience is this. Yep, here what we have put the age. So age is clearly again the flat. Here you can see that this is a flat one. This is a platykurtic. Okay, that's how we can leverage the kurtosis to understand the shape of the data distribution. So your skewness is to understand the which side it's been distorted, and the kurtosis is understand the degree of peakiness and then heaviness of the tails.